Okay, so let's add a little bit of complexity. Let's add a cliff to our problem. So here's our problem. Let's have a cliff that looks like this. Let's make that let's say a 10-meter cliff, so it's maybe the top of a one-story building, and let's just be right on the edge here, and let's just have a standard, let's say 40 degrees above the horizontal, and let's send it off with 30 meters per second as my initial velocity. And again, we can ask all the standard questions. How high, how far, time in air, and final velocity. All right, now this is getting kind of boring because we've done this so many times. We know that that 30 meters per second isn't in our coordinate system. Let's just, for fun, put our coordinate system down here at the bottom of the cliff. Still x and y. Doesn't matter where you put it, it just means that the direction, that 30 meters per second, isn't in x or y. So we have to take our 30 meters per second and we have to break it up into a v0x and a v0y. Notice that it's important that I'm going to get from the beginning of the 30 meters per second arrow to the end. I have to go to the right and then I have to go up. I don't want to mix up the directions of my arrows because otherwise I'm going to end up having problems later. So I know, oh, and I know that the angle is 40 degrees, right? So I know that the sine of 40 degrees is v0y over 30, right? Opposite over hypotenuse. So v0y is equal to 30 sine 40, or, and I'll just plug that into my calculator right now, 30 sine 40, again remembering to be in degree mode. Let's just say 19.28 meters per second, and I will just keep that extra digit till for now, and I will fix it later in terms of significant figures. Cosine of 40 degrees is equal to adjacent v0x over 30, so v0x is equal to 30 cosine 40, or v0x is equal to 30 cosine 40 in my calculator is equal to 22.98 meters per second. So I know my v0x, I know my v0y. I can go over here. And notice I'm doing all of this just automatic. I haven't really even thought about what my problems are going to be yet. I'm just going to go over here and say I've got v0, vat, delta x in the x direction and in the y direction. I know my initial velocity in the x direction, 22.98 meters per second, y 19.28 meters per second. Accelerations for free, minus 9.8 meters per second squared. Okay, now I have to think. What am I interested in? If I'm interested in, first of all, how high the ball is going to go, right? The path is going to be up here somewhere. So I'm interested in for how high this height, that delta y, and that is to the top of its path, the magic word, to the top, and at the top the y velocity is 0, and so I'm only going to do part of that problem to find my delta y, and I know that v squared, whoops, v squared equals v0 squared plus 2a delta y, or delta y is equal to v squared minus v0 squared over 2a. And I can plug in numbers. V squared is 0 minus v0 squared, which is 19.28 squared all over 2 times minus 9.8. I end up with 19.28 squared divided by 19.6 is delta y is equal to 18.97 meters. What is that delta y? Let's make sure that we're clear about what that is. that delta y is the height from the beginning, where it's 19.28, to the height where it's 0. So that delta y that I'm calculating, this delta y right here, between the beginning and the top, is really beginning to the top, that delta y. And I want the whole thing, so my maximum height is going to be equal to 10 meters plus 18.97 meters, or 28.97, and I'll just say to 0.97, I don't know, to 3 significant figures or 2 significant figures, 29 meters. How high? 29 meters, and I'm going to just tell you explicitly from the bottom. All right, so you don't get confused. 29 meters from the bottom of the cliff. Okay, so that's my how high question. How high? Now, how far does it go? How much time is it in the air? So I know if I want to answer how far, let's just stick with how far does it go? What's my question? I'm interested in this distance right here. How far does it go? What's my delta x? All right, so how far? I know that I'm going to need a different column of variables. So this one is going to be v0 vat delta y, and it turns out that I wrote in the wrong place. My initial velocity is still 19.28 meters per second. My acceleration is still minus 9.8 meters per second squared. My final velocity is not 0 anymore. Final velocity is not 0 down here, but I know my delta y. I started up here and I ended down here. So I went from start clear to the finish, which means my delta y is negative 10 meters. So now I can solve for the time. Say delta y is equal to v0t plus 1/2 at squared. So negative 10, because I lost, is equal to 19.28t minus 4.9t squared. This is 1/2 times negative 9.8. So I'm just combining those terms quickly in my head because we're almost bored with these kinds of problems already. And now we notice that we have a quadratic equation, and we hope that we have the quadratic in our calculator. Minus 4.9t squared plus 19.28t plus 10 equals 0. And I'm going to guess that I don't even have it in this calculator that I have. Oh, maybe I do. Let's look. 3, 2. I do. That's beautiful. So I'm going to just plug in my quadratic equation. It's going to be, my A term is negative 4.9. My B term is 19.28. My C term is positive 10 because I brought it from the other side of the equation. And I get T is equal to negative 0.454 and 4.49 seconds. And I generally am going to take the positive one, though not always, but in this case, I'm moving forward in time to throw the thing off the cliff, so I'm going to take this guy, and I'm going to say that my time is 4.49 seconds. I'm going to share that time over here, 4.49 seconds, and I'm going to say delta x is equal to v0t plus 1/2 at squared. Notice that that acceleration in x is 0, so delta x is equal to 22.98 meters per second times 4.49 seconds. 22.98 times 4.49. We get a distance of 103 meters for delta x. So how far did it go? 103 meters. And we, in the process of solving that, found out that the time in the air was 4.49 seconds. All right, so we're getting close. We're finding that. So we have the how high question, we have the how far question, and then finally we can say what's the final velocity. We still don't know the final. We know the final velocity automatically. Over here, final velocity, because the acceleration is 0, 22.98. Over here, we don't know the final velocity, but that we can find pretty easily. Final velocity. So velocity for x is 22.98. Velocity for y equals v0 plus at. So it's going to be 19.28 minus 9.8 times 4.49. 9.8 times 4.49 is 19.28, and we end up with a final velocity of negative 24.7 meters per second in the y direction. And again, we have to put that back into component form. So we have Vx is equal to 22.98, Vy is equal to negative 24.7. So I'm going to end up with a hypotenuse in this direction and an angle in this direction. And I can just use Pythagorean theorem, 22.98 squared plus 24.7 squared. Square root that, and I'm going to get a hypotenuse of 33.7 meters per second. And I'm going to use my trig function. So we use Pythag to get that, right? And then my favorite trig function, tan theta is equal to opposite 24.7 over adjacent of 22.98, which is 1.07. So theta is the inverse tangent of 1.07, or 47 degrees. So we could say up here, my final velocity is 33.7 meters per second, 47 degrees below the horizontal. And again, we have, for your viewing pleasure, all the answers to all your questions.